Bismillahirrahmanirrahim. Hi everyone, I hope you are all doing well. My name is Azmat Ali and currently I am working as a lecturer in mathematics at Government Shalimar Graduate College, Lahore, Pakistan. I welcome you all in class of O-level mathematics. So far we have discussed about further sets, and in the last lecture we discussed word problem related to Venn diagram. In today's lecture, we will discuss the same topic because this is an important topic. So we will discuss some questions related to this topic. The book that I am following here, this is the new Syllabus Mathematics series, 8th edition, and this is D4, written by Dr. Yeap Ban-Har. Possibly, if you are not following this book, that's why I am writing the statement of question number 6 available in this book. Near to me, this book is well designed for O-level mathematics content and your final exam. So let us discuss the word problem. We have 253 participants were asked to complete a survey about their fruit preferences. 179 of them like durian, while 43 of them like neither durian nor apple. How many participants of the survey like apple but not durian? When we discuss the word problem related to Venn diagram, in case of two sets, suppose we have two sets A and B, then it is possible that we have to find their intersection, their union, union of their complement, intersection of their complement, the union of complement of first set with the other, the intersection of the complement of first set with the other, similarly the union of first set with the complement of other, and the intersection of first set with the complement of other. So these are the possible quantities that we can find here. And further, lastly, it is also possible that we have to find the complement of whole union and the complement of whole intersection. Further, the important identity that we will use here are the De Morgan laws. How can we define the De Morgan law? You know, the De Morgan law can be defined as the complement of the union A and B. This is equal to A complement intersection B complement. And the second De Morgan law is A intersection B whole complement. This is equal to A complement union B complements. So these are the following possibilities that can we find, or some of them will be given in the question when we have two sets A and B. So let us write the given data that we are given in this question. 253 there are the total 253 participants. This represents actually the size of the universal set. In this book, the universal set is denoted by the Greek letter xi. This is the Greek letter xi. Now the number of total participants is denoted by n of xi. This is equal to 253. After survey, which is for fruit preferences, 179 of them like durian. Durian is a fruit name. So let D, this set D represent the participant who like durian. So their number is 179 here. While 43 of them neither durian nor apple. It means this is the neither and nor, both of the words used for complement. So this is the number of participants who neither like durian, mean D complement, nor apple, intersection A complement. This number is given by 43 here. How many participants of the survey like apple but not durian? In the last, we have to find the number of participants only like apple but not durian. It means we have to find apple intersection complement of D. This is our requirement. Firstly, we can solve this question without detailed steps. We can solve this question just mentally or orally. We make a diagram, Venn diagram here. This is my Venn diagram. This rectangle represents the universal set. This is the first set that represents apple, and this is the second set that represents the durian. And this is the case of intersecting sets or overlapping set also, you can say. Now, what is our target? We have to find the portion that consists of the elements just like apple but not durian. It means we have to find the number of elements in this portion. This is our target, the number of elements that lies here, but not the part of D. Actually, A intersection D complement, A intersection D complement is actually A difference D. This is A difference D here. So, we need to find this area. Now, the given information is the number of candidates who neither like durian nor apple. That candidates, that participants will lie here. A complement intersection D complement. The outside area, this outside area represents the number of participants who neither like durian nor apple. So this represents A complement intersection D complement. Now, if we find the complement of this intersection, if we find the complement of A complement intersection D complement whole complement, what is this is equal to, by using De Morgan law, this can be written as complement of complement, intersection will change in union, D complement complement. This is equal to A union D. So, and from Venn diagram you can also see here, when you take the complement of this green area, your resulting portion will be lies in this circle. That represents the union of two sets A and D. So, what is the mentally or orally trick that you can use? You will just take the complement of this number 43 that represents the number of participants who neither like durian nor apple, 43. The complement of 43 under universal set 253. So we subtract 253, 43 from 253. This gives us 210. Actually, 210 represents the number of A union D. Now we have to find just the number of elements that lies here in this portion. If you observe that, to find A intersection D complement, this is actually equal to A union D difference D. If you subtract D, this circle D from the union, you can obtain this green area. Now, what is A union D? A union D is 210 minus what is the number of elements in D? Number of elements in D are 179. So this gives 31. So the answer is 31 here. So this is the trick that you can use directly here, but sometimes in the paper you have to ask that you have to explain each step in detail. So if you solve this question properly by using by mathematical steps, so firstly you will mention that as A union D whole complement by using De Morgan law, this is equal to A complement intersection D complement. Further, by using the definition of complement, this can be written as epsilon xi, that is the universal set, minus or difference A union D. You can use the notation rather than this A intersection D. This is A complement intersection B complement. Now taking the number n on both sides, this gives n xi minus n of A union D here is equal to n of A complement intersection B complement. N xi is given 253 minus n of A union D is equal to n of A complement intersection D complement. Sorry, what are the number of, this number is 43. Subtract 43 from both sides, this gives 243 minus 43 is equal to n of A union D. This gives n of A union D is equal to 210. That is the same as previous we have found. This is to 210. Next, but we have to find A intersection D complement. Again, using the identity in case of overlapping sets or intersecting sets, you can also overlapping sets and intersecting sets both have the same meaning. Lastly, using identity, n of A union D is equal to n of A plus n of D minus n of A intersection D here. Further, if you notice from the Venn diagram, this green portion is also equal to, if you subtract this intersecting area, if you subtract this intersecting area from the whole set A, then you can again find A intersection D complement. It means A intersection D complement can be found by two ways, also by this identity, and this can also be found as set A difference A intersection D. It means this can also be written as A difference A intersection D. So if you combine n of A with this can be written as n of A intersection D complement, which is actually A difference D here, plus n of D here. What is n of A union D? This is 210. This is our required. N of D is 179. Subtract 179 from both sides. This gives n of A intersection D complement. This is equal to 31. So this is the complete way to solve this question mathematically. In the similar way, you can solve question number 7 available in this textbook. The question number 7 is here. In a class of 38 students, 19 students have traveled to Malaysia, while 4 students have neither traveled to Malaysia nor Indonesia. Find the number of students in the class who have traveled to Indonesia but not Malaysia. There is the same scenario of question number 6 is available in question number 7. Just the difference in question number 7 is of the number and the name. In question number 6, we have participants who like fruits, but here we have a number of students that travel to Malaysia. So I hope you can do question number 7 by yourself. Still, if you feel any problem or any complexity in this question, you can comments me. Inshallah, I will reply you. If you find my lectures helpful, kindly like, share, and subscribe my channel. In the next lecture, we will discuss some more complicated questions related to world problem. So see you in the next lecture. Take care. Allah Hafiz.